Today, we're diving into a paper titled Self-Taught Evaluators, which explores a novel approach to training evaluation models for large language models, LLMs. The traditional method relies heavily on human-annotated data, which can be expensive and time-consuming. This paper proposes a self-training method that uses synthetic data instead. What are the main challenges associated with traditional methods for training evaluation models?
The primary challenge with traditional methods is the reliance on human annotated data. Collecting large amounts of high-quality preference data from human annotators is costly and time-consuming, especially for complex tasks like coding or mathematical reasoning. Furthermore, as LLMs improve, these annotations become outdated, as they are based on judgments of older, less performant models.
So this paper proposes a self-training approach that eliminates the need for human annotations. Can you explain how this method works?
The paper proposes an iterative self-training scheme that uses synthetically generated data. It starts with an initial seed LLM and a set of unlabeled instructions. The method then generates contrasting model outputs for each instruction, where one output is designed to be inferior to the other. This creates synthetic preference pairs.
How does the model learn to distinguish between the good and bad outputs?
The model is trained as an LLM as a judge, which means it generates reasoning traces and judgments for each preference pair. These judgments are then labeled as correct or incorrect based on the synthetic preference pair design. The model is then fine-tuned on this labeled data, resulting in an improved LLM as a judge.
So the model essentially teaches itself to evaluate by generating its own training data.
Exactly. The process is iterative, meaning the improved model from one iteration is used to generate even better training data for the next iteration. This allows the model to continuously improve its evaluation capabilities.
That's fascinating. Can you elaborate on how the synthetic preference pairs are generated?
The paper uses a prompting technique to generate these pairs. For each instruction, the model first generates a baseline response. Then, it generates a modified version of the instruction, designed to be highly relevant but not semantically identical to the original. The model then generates a response to this modified instruction, which is expected to be a poor response to the original instruction. This creates a synthetic preference pair where the baseline response is considered better than the response to the modified instruction.
So the model is essentially creating bad responses by manipulating the instructions?
Yes, that's a good way to put it. The model is learning to identify what constitutes a bad response by generating responses that are intentionally flawed.
This is a clever approach. What are the results of this self-training method?
The paper reports significant improvements in evaluation accuracy. Starting with a strong LLM, the self-taught evaluator achieved an accuracy of 88.3 on the reward benchmark, which is a standard benchmark for evaluating reward models. This performance matches or outperforms reward models trained with human annotated data.
That's impressive. So this method is able to achieve comparable performance to models trained with human annotations without using any human annotations at all.
Yes, that's correct. The paper demonstrates that self-training with synthetic data can be a viable alternative to traditional methods for training evaluation models.
This has significant implications for the development of LLMs. Can you elaborate on the potential benefits of this approach?
This approach offers several benefits. First, it eliminates the need for expensive and time-consuming human annotations. Second, it allows for the development of evaluation models that are not limited by the availability of human annotated data. Third, it enables the creation of evaluation models that are tailored to specific tasks or evaluation criteria.
Are there any limitations to this approach?
Yes, there are some limitations. One limitation is that the model's performance is dependent on the quality of the initial seed model. If the seed model is not sufficiently aligned with human preferences, the self-taught evaluator may not be able to learn effectively. Another limitation is that the method relies on the model's ability to generate synthetic preference pairs that accurately reflect human judgments. If the model is not able to generate high-quality synthetic data, the performance of this self-taught evaluator may be compromised.
So the success of this method hinges on the quality of the initial seed model and its ability to generate realistic synthetic data.
Yes, that's correct. The paper acknowledges these limitations and suggests that further research is needed to address them.
To wrap up, can you summarize the key contributions of this paper?
The paper introduces a novel self-training approach for training evaluation models for LLMs using synthetic data. It demonstrates that this approach can achieve comparable performance to models trained with human annotations without using any human annotations. The paper also highlights the potential benefits and limitations of this approach, suggesting that it is a promising direction for future research.
Thank you for explaining this fascinating research. It's clear that self-training with synthetic data has the potential to revolutionize the way we evaluate LLMs.